Hello, I'm Astronaut Randy Bresnik. At the end of July, I'll be launching out of the Baikonur Cosmodrome in Kazakhstan. I'll be launching aboard a Soyuz rocket inside of a Soyuz spacecraft atop that rocket. Now, when I launched aboard the Space Shuttle Atlantis in 2009, we had 7.5 million pounds of thrust for a 4.5 million pound vehicle, and we had 6 of us on board the Space Shuttle. In contrast, we've got the Soyuz spacecraft, which weighs, and Soyuz rocket weighs much less and has 1 million pounds of thrust, but there's only 3 of us inside. And we're inside a tiny little capsule the size of about 2 lounge chairs pushed together. And so it's much more intimate gathering than it was within the Space Shuttle. Because Space Shuttle, we had the flight deck and we had the mid deck, and we separated the crew in those areas. And so we expect the launch to be just as amazing and dramatic, the fact that we're beating out gravity with the thrust of our engines to reach orbital velocities. But we also expect that, well, we don't have windows out in front of us because we're in a capsule. All we have is the 2 portholes on the side. So the view will not be quite as good until we're actually able to get up to orbit, get to zero gravity, have main engine cut off, and be at 17,500 miles an hour in orbit. Now, over to Marty and Beth so you can learn more.
Thanks, Randy. So, Marty, you want to make some rockets?
Oh, I love rockets. We can launch them. We're inside. We're going to get in trouble for launching rockets inside.
Actually, I was thinking that we could make balloon rockets.
Oh, I love balloons. I love rockets. This is going to be awesome.
Okay, so the basic physics of rocketry is that there's a high-pressured gas inside a rocket. And when you release that gas, the rocket goes in the opposite direction as the gas coming out.
So in order to create a force, a push or a pull, you have to do something with a balloon. We'll use the air that is experiencing a lot of pressure. Pressure is the amount of force over an area. The more you blow up the balloon, the more pressure there is on the inside. So the more force there is pushing out in every direction on the balloon's surface. When you release the opening of the balloon, the air is forced out in that direction, which causes the balloon to go off the opposite direction.
You ready?
Absolutely. Nice! That was awesome. So Beth, how are we going to get the balloon to go in the direction we want it to go?
Well, first I've blown up this balloon, right? And what we've done is we've put a string across the room, and I've threaded that straw through there. So what I need you to do is to tape the balloon to the straw for me. And then you want to give me a countdown?
Sure. 3, 2, 1, launch! Oh, that was awesome! If you want to do this in your classroom, be sure to head over to the website and check out the lesson plan. And while you're there, think about how do you make the balloon go faster or farther?